Hi, we're Open Source 23213, and we're going to be talking about how teamwork makes the design work. So basically what we're going to be talking about is how strategy or alliance strategy affects how you design your robot from day one. So your first big strategy decision, what are you going to decide the task that you're going to be doing basically the whole season? So from day one, we target the least desirable, or I'd say the more difficult task. We use comparative analysis, but also go online and see what other teams are focusing on so we can kind of see what is in demand. So this year we did one for specimens versus samples, and we noticed that specimens were a higher point opportunity, and also people in our area were mainly focusing on baskets, and we wanted to make sure that we could complement those who were doing baskets.
As Sydney stated, we believe in targeting the least desirable or the most difficult task, which makes us an ideal alliance partner, which is our ultimate goal at the end. In finals, if we're not a captain, we want to be everyone's first pick. In center stage, we focus entirely on building mosaics because a lot of the teams focus on moving white pixels from the stacks. For Into the Deep, we focus on specimens because most of the teams in our region were focusing on baskets in early in the season. Are there sacrifices? Absolutely yes. Because we tend to specialize, our tiebreaker points and overall scores can suffer early on in the season. We also rarely post world record solos. It's important to remember, though, that we're not trying to be the best bot in the world, we're trying to be the best alliance partner in the world. In center stage, for example, we had a very modest 2+2 auto, but we built to complement almost everyone. We could start from the audience side, which was rare in our local league and Houston region, and navigate onto the center line or outside edge in the field as needed. For Into the Deep, we focus entirely on specimens. We never ran a spec auto and the baskettelli unless we had some sort of mechanical failure. We wanted to showcase our specialty and we wanted the best basketball in the state and the world to know who we are and what we could do.
Okay, so we're going to talk a little about our design process and kind of how we go about doing that from day one. So I just want to say first off, we did not create these terms. We learned them from FRC Robonauts from actually another FLYSET event. But we have Crayola, silver, and gold prototypes. Um, Crayola is like your very basic CAD, 3D prints mostly. They're for like test fit purposes or even like wondering if this is even possible. We go through quite a few Crayola prototypes early in the season or when we're trying something new, and every once in a while we hit a dead end, but most of these do progress to silver. And then I just have some videos. This is one of our Crayola CADs from this year for the first one of our group. So silver, it's much more refined and it's usually 3D prints used for teleop driving and auto tuning programming. We usually have most of our silver prototypes in mid-October. We have a lot of silver prototypes over the course of a season. There's a huge tub of our HQ just filled to the brim with dead silvers. Most of these will go to a scrimmage or league meet. At the very least, we'll invite teams over to practice with us. They're battle tested and iterated constantly. And I do want to say a lot of the designs kind of stay in the silver phase because not all the gold isn't always necessary. And these are some more videos of our robot with silver prototypes. Okay, so gold isn't really the next step after silver so much as it is a prototype that we have to be really, really sure that we're ready for because it needs to be machined out of aluminum or carbon fiber. In center stage, to be honest, we had very little gold other than our chassis. Our intake and transfer system were constantly changing that year, so we never really went with a gold design. However, for Into the Deep, we had quite a bit of gold as early as Christmas because we went with a very simple design and simple concept this year, which allowed us to get there much quicker. And we needed the strength of the more durable materials because our method for clipping is fast and aggressive. With that being said, gold is like the extremely finished product, and you want to make sure that you're not really changing it throughout the season because that can be really expensive. Our example that we're showing right here is we had our one of our arms made out of carbon fiber this year, and we have yet to change it since then. Okay, with that being said, the engineering the process isn't always going to be linear. If you do end up getting a gold design and realizing this isn't going to work, don't stick with it just because you've got it machined. Um, I'd say basically everybody has a copy of the design process in their portfolio, so I'm not really going to go over that specifically. But for our prototyping and stuff, you want to design something, print it, test it, figure out what doesn't work, redesign it over and over. We go through a lot of filament every season, like a ton, and a robot can be really chaotic colors because we usually just use whatever filament is donated by sponsors. But yeah, iterating never stops, so don't get stuck on something just because you think it's done. We've been working on a robot forever, and basically every day we change the part. I see some questions in the chat. I'll answer them at the end. So, what is going to be like one of your first big design decisions? So, personally, my favorite part of our robot is the gripper. So, it's the thing that I focus on every year. And I'm just going to kind of talk about two of the different grippers and why you would make different decisions based off of that. So, there's kind of like passive intakes or claws, and these are useful for picking up like large or odd shaped, randomly stacked elements, whereas an active intake is where basically it keeps on going and it can rather suck in the elements through wheels. So this year we decided that we wanted to go with an active intake because it was fast and allowed for a little bit more, I guess, tolerance when we were trying to get all the samples from the sub because they were going to be at random angles. They're not going to be nice. But with that being said, no matter what you choose, you need to be reliable, consistent, control it, and remember, if you touch it, you own it. That basically means if we get a part, we're not getting rid of it. We're going to put it somewhere. We're going to do something with it. You don't want to just be wasting time. So I'm going to talk a little bit about our active intake this year since that's the one we went with. So this year we had a roller and wheeled intake, and that was because we were focusing on the specimens. We needed something that was like pretty strong, and we used this intake for both the picking and scoring. And that was because it was super controllable. It was pretty easy to operate. Some disadvantage is this year, elements could get jammed in it if they were bad. And then the one that's next to it is Green Machine's intake. If you know them, we're like pretty close with them, but they let me borrow their pictures for this. So they did a tubing and zip tie intake, and they thought that that was very fast and it was able to collect multiple elements, which was bad for this year, but in future years it could be better. So basically, I've just been yapping about different intakes, but how does this actually fit into us being a specialist? So the design process can be much more refined if you know exactly what you want to accomplish. So for Into the Deep, we wanted specs, simplicity, and speed. So every time we were designing a part, we kept those three things in mind, which is why we made these different decisions. In this case, we wanted to get a part and then get it to our human player as fast as possible, which is why we didn't make a transfer system because we thought that that could be something that would slow us down a little bit. Um, and then when we go to clipping specs, we wanted to be really, really quick. And a lot of teams clip from underneath, but with our design, we kind of just slam it into the bar. And this can be aggressive, which is why we have to be extremely robust, but it was also really fast. And here's a video of our auto, just kind of basically we hit things a lot. So there are some design limitations when specializing. So our main gripper this season was super heavy. This didn't truly matter when we were running specs because the high bar isn't very far off the ground. But a side effect was that our arm wobbled like crazy when we tried to attempt baskets. So we were definitely better at doing specs. We could do baskets, but it was harder for us because our robot wasn't built for that. We came up with some small solutions for this, like using rubber bands, programming fixes, but in the end of the day, we're not a basket bot. We were only really a spec bot. But you still want to be able to be adaptable because there were some teams in our local area that couldn't do baskets at all. And we didn't want to have to be a bad alliance partner and say, oh, well, we can't do that either. And we're kind of just cooked sitting there because we can only do one thing. So never specialize so much that you can't switch jobs. You never know what qualifier you will throw at you. So that's what I said that example. And then also when we were at Worlds, we were in a league with a lot of spec bots or a division with a lot of spec bots. So we made sure we had a bucket auto ready in case they were better at us or they could get a lot more specs. So this is example of our bucket auto. It was pretty slow, but it was reliable.
Open source and open house. So a big part of our strategy and consequently design is in fact dependent on us forming very strong alliances. We do this by opening our doors to as many teams as possible. If you ever come to our HQ, we share everything, show everything, we drive and strategize with everyone. We don't keep anything a secret. We're really bad about at it. We're really bad at it, actually. We invented a 5+1 auto, immediately posted it, and then a dozen teams were running it in days later. But yeah, we love collaborating. So do you have any questions? If so, contact us in our link tree over there and scan the QR code.
And I also see all the ones in the chat. I'll go through and answer them right now.
That's not the question.
Yeah, so we can go ahead and probably like alternate between online and in-person questions. And we can maybe take like 3 or 4 questions. And I'll go ahead and let you start with any online questions that there are.
So first one I see is how much do you use 3D printing in your final designs? Our robot's mostly 3D printed. I'd say if you've ever seen a picture of a robot, which you just saw a couple in the slides, anything that's in color, that's 3D printed. And as far as final design, it's really expensive to get some stuff machined sometimes, so we use it a lot. How much does all the filament cost? It really depends. A lot of it we do get from sponsors that we've reached out to, but from Amazon, if you get like the cheapest color, I think it's around $30. And that's usually what we end up doing.
We can go ahead and take an in-person question as well. So if anybody in the auditorium here has a question, just raise your hand and I'll bring the mic to you. If not, then we can also continue with any remote questions that we have, which I see there's a lot in the chat here, so.
Okay. We have two 3D printers. We have a Prusa and we also have a Snapmaker, but I've also used a raised 3D printer and a Bamboo. I'm gonna completely honest, I can't really tell you the best 3D printer because a lot of that depends on like price point and size. For us, we got ours one from Facebook Marketplace and we're just happy to have it. But I have heard a lot of good things about the Bamboo. I personally prefer an active intake. I think it's just a little bit easier on your drivers because it doesn't have to be as precise. And now we've built an active and a passive one at this point because we have a second arm now. And I just think it's a little bit easier as far as giving you some leniency when you're driving.
I think we can take maybe one more remote question.
Okay. Do you prioritize focusing one type of scoring at the beginning? In the beginning, kind of depends on the game. I still think
So we have
we
a
specialize.
quick, excuse me.
Yes.
So we have a quick question. So why did you guys pick Crayola instead of Onshape?
Crayola is just a label. It's just means like your very first CAD. We use Fusion 360 though.
Okay, fantastic presentation. Awesome questions. Everybody give open source one more round of applause.